Hi students, in this video we are going to learn about equations of plane in intercept form. Before we get into this equation of plane in intercept form, I'll just recollect a formula. That is, if a plane passes through three fixed points x1, y1, z1, x2, y2, z2 and x3, y3, z3 means then the equation of the plane is given by determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus y1 equal to 0, because we will use that concept here to find the equation of the plane. That's why I recollected that formula. Intercept equation of a plane in intercept form means, for example, if a line intercepts x-axis, y-axis means then the distance from origin to that point will be given, from which we can calculate the coordinates on x-axis. For example, if a line intersects x-axis whose intercept value is 2 means from the origin it cuts the x-axis at 2 units distance. So the coordinates of that point will be 2, intercepting point of x-axis and the given straight line is 2, 0, because 2 gives the distance from the origin and on x-axis y coordinate value is 0. We will apply that concept as well as the 3-point formula. 3 points are given means how to write the equation of the plane. Those two concepts will be used in this equation of a plane in intercept form. I'll read out now. The distance of a point from origin where a line or plane crosses an axis is called intercept for axis. For example, if the plane cuts x or x, y, z axis at a, b, c means the distance from origin to the point of intersection of the plane on x-axis is a units, and then it cuts the y-axis at b means the distance from origin to that point on y-axis is b units distance. Similarly, from 0 to c on z-axis, if we know that from origin this distance is a units means the coordinates of this point, intersecting point of the plane and x-axis is a, 0, 0. Similarly, here it cuts the y-axis at b means we know that 0, b, 0. Similarly, here it can be written as 0, 0, c. If we know these 3 points, we know how to write the equation of the plane using this form. That is what is explained here. The distance of a point from origin where a line or plane crosses an x-axis is called intercept. Consider the system of coordinate axis with O as origin. Consider a plane not passing through the origin, which makes intercepts of lengths a, b, c with x, y, z axis respectively. Let the plane meet the coordinate axis at capital A, capital B, capital C. These are the points name, such that OA is equal to A, that is from origin to that point A, the distance is A. OB is equal to B, OC is equal to C. Then as we know very well, the coordinates of A, B, C are A, 0, 0, that is x1 is A, y1 is equal to 0, z1 equal to 0, and then y-axis 0, b, 0, x2 is 0, y2 is b, z2 is 0, and the third coordinate is x3 is equal to 0, y3 is equal to 0, z3 is equal to c. Now we know these 3 points. We must write the plane equation which passes through the given 3 points. Then the formula, as you know, determinant of this. So in place of x1, y1, z1, we will substitute those corresponding value. When we simplify it, we get this form. What we will do is we will divide the entire equation, both sides of the equation, by a into b into c. Finally, we will get this form: x by a plus y by b plus z by c is equal to 1. We have seen the same type of formula in 2D as straight line, intercept form of the straight line, x by a plus y by b is equal to 1. Here we are dealing with 3D geometry, hence x by a plus y by b plus extra one term, that is z by c, is equal to 1, right? When the normal Cartesian form of the plane is given, means if you make that right side value as constant, and then if you divide the entire equation by the given constant, we will get 1 in the right hand side. Then we can convert it in the intercept form. While we solve problems, you will understand how to convert the normal Cartesian formula into intercept form. Now you just understand how the formula of equation of plane in intercept form is derived. Just remember this formula: x by a plus y by b plus z by c is equal to 1, where a is the x-intercept, b is the y-intercept, c is the z-intercept. This is the intercept form of the plane. Now we will get into the problems. The first question is, find the intercepts on the coordinate axis cut by the plane r vector dot 2 I cap minus 4 j cap plus 3 k cap equal to 12. Now here plane equation is given. Now we need to find out x-intercept, y-intercept, z-intercept. For that, first we must convert this vector form of the equation into Cartesian form, because here we are dealing with Cartesian system, hence vector form should be converted into Cartesian form. Cartesian form means ax plus by plus cz is equal to d, where a, b, c are direction ratio of the given plane, direction ratio of the normal. Hence this vector equation of the plane can be converted into Cartesian form as 2x minus 4y plus 3z is equal to 12. You just observe it. The equation of the plane in Cartesian form is 2x minus 4y plus 3z is equal to 12. Now if you observe it, right hand side of the equation is 12, but in intercept form of the plane equation we need 1 in the right hand side. Hence, in order to make the right hand side as 1, we will divide the entire equation, that is both sides of the equation, by 12. So we get this value: 2x divided by 12 minus 4y divided by 12 plus 3z divided by 12 is equal to 12 divided by 12. When we simplify this, we will get this form, but you should make sure that coefficient of x is plus 1, coefficient of y is plus 1, coefficient of z is plus 1, and then this ABC can be negative. But if you divide it minus 4y divided by 12, some students will write it as minus y divided by 3, and they will say b value is equal to 3. Always the coefficient of x, y, z in the intercept form should be plus 1. So they divided by minus 3. This minus has been brought down here. I hope you can understand this. So now if you compare it, it is in the intercept form. So x by a, so a value is equal, that is x-intercept value is 6, y-intercept value is minus 3, z-intercept value is plus 4. I hope you understand this problem. Now we move on to next question. Write the sum of the intercepts cut off by the plane r vector dot 2 I cap plus j cap minus k cap minus 5 equal to 0 on 3 axes. What we need to do is, first we need to calculate x-intercept, y-intercept and z-intercept. After that we need to add all of them together to get the final answer. As you know very well, in order to find the x-intercept, y-intercept, z-intercept, we need to write the plane equation in intercept form. In order to write the equation in intercept form, it must be in Cartesian form. The plane equation must be in Cartesian form. But if you observe it here, the plane equation is in vector form. Hence it has to be converted into Cartesian form. You know how to convert vector form into Cartesian form. Here the Cartesian form of the equation will be 2x plus y minus z is equal to plus 5. You just observe it. 2x plus y minus z is equal to plus 5. You know that in the intercept form, right hand side value must be plus 1. Hence we are dividing both sides of this inequation by plus 5. So we get 2x by 5 plus y by 5 minus z by 5 equal to 1. I already told you the coefficient of x, coefficient of y, coefficient of z in intercept form must be plus 1. So what we need to do is here, this two numerator and denominator of this expression, this term can be divided by 2, so that x divided by 5 by 2 will come. You observe it, hence the coefficient of x is 1. Now already here coefficient of y is 1, so no problem here, but if you observe it here, coefficient of z is minus 1, hence numerator and denominator of this term should be divided by minus 1, hence we will get plus z divided by minus 5. Now it can be compared with intercept form of the plane, that is x by a plus y by b plus z by c is equal to is equal to 1, where a value is equal to 5 by 2, b value is equal to 5, c value is equal to minus 5. Those are the intercept values. You just observe it, a is equal to 5 by 2, b is equal to 5, c is equal to minus 5. Now we need to find out sum of the intercepts, hence they are adding 5 by 2 plus 5 and then minus 5. We are getting the final answer. I hope you can understand this problem. This problem is similar to what we saw in the previous problem. I hope you can understand this clearly. Now I move on to next question. Find the vector equation of the plane with intercepts 3, minus 4 and 2 on x, y, z axis respectively. Now here they have given x intercept, y intercept and z intercept. So we can write intercept form of the plane equation. After that it has to be converted into vector equation. What we can do is, after writing plane equation in the form of intercept, it can be converted into Cartesian form. From Cartesian form we can move on to vector equation. So using these values we will write the intercept form, that is x by 3 plus y by minus 4 plus z by 2 is equal to 1. That is the intercept form of the equation. In the intercept from actually in the Cartesian form we will not have these denominators, hence what we can do is we can multiply both sides of the equation by LCM of the denominator, so that these denominators will disappear. So what we do is we take the LCM of 3, 4, 2. We know that LCM of 3, 4, 2 is 12. Hence we are multiplying both sides of the equation by 12. So 12 into x divided by 3 will give us 4x. 12 into y by 4 will give us minus 3y. Similarly 12 into z by 2 will give us 6z, which is equal to 12, because we are multiplying both sides by 12. Now we got the plane equation in Cartesian form. It can be easily converted into vector form as r vector dot 4i cap minus 3j cap plus 6k cap equal to 12. I hope you understand this problem as well. Now we move on to next question. Find the equation of the plane passing through the point minus 2, 1, minus 3 and making an equal intercept on the coordinate axis. Since it makes equal intercepts on coordinate axis, means if the x intercept is equal to a, means y intercept value is also equal to a and z intercept value is also equal to a. Hence the intercept form of the plane equation is x by a plus y by a plus z by a is equal to 1. Here if we find out the value of a, we can find the equation of the plane. So in order to find the a value only, they have given this minus 2, 1, minus 3. Through this point the plane passes. Hence the plane equation must satisfy this point. So in place of x we can substitute minus 2, in place of y we can substitute 1, in place of z we can substitute minus 3. Actually they simplified this, they have taken LCM and brought it to the right side. So they substituted in this equation, in place of x they substituted minus 2, y in place of y they substituted plus 1, in place of z they substituted minus 3. That you can see here. When they simplify it, they get the value of a is equal to minus 4. Now this value of k can be substituted here and then we will get the equation of the plane. So equation of the plane is x plus y plus z is equal to minus 4. I hope you understand this problem. Now we move on to next question. Find the equation of the two planes passing through the points 0, 4, minus 3 and 6, minus 4, 3 if the sum of their intercepts on the three axes is 0. Now we need to find out the equations of two planes. Those two planes are passing through these 2 points, and if the sum of their intercepts on three axes is 0. We know that equation of the plane having intercepts a, b, c on coordinate axis is x by a plus y by b plus z by c is equal to 1. Since it passes through these two planes passes through these 2 points, this equation should be satisfied by these 2 points. So in place of x they are substituting 0, in place of y they can substitute 4, in place of z they can substitute minus 3. So we have substituted this value in the equation. The same plane passes through this point also, hence this point also must satisfy the equation. Hence in place of x they are substituting 6, in place of y they are substituting minus 4, in place of z they are substituting 3. Our aim is to find a, b, c value. So we have to solve this. If you add these two equations, you just observe it, plus 4 by b minus 4 by b, so that this term will get cancelled, as well as minus 3 by c plus 3 by c will get cancelled, and we will get the final value of, when we add right hand side we will get 2. So 6 by a is equal to 2, from which we can say a value is equal to 3. Our aim is to calculate ABC so that we can write the equation of the plane. We got the first value, that is a is equal to 3. And it is given that sum of their intercepts on the three axis is 0. So intercept value, sum of the intercepts on the three axis is 0, means a plus b plus c equal to 0. We already calculated the value of a, so we are substituting it. So 3 plus b plus c is equal to 0, from which we can say c is equal to minus 3 plus b. Since we get the value of c, it can be substituted in any one of these equations. Since it is easy for us to calculate the value of b here, we are substituting the value of c in this equation. So we get 4 by b minus 3 divided by, in place of c we are substituting this 3 plus b. So when we do cross multiplication, when we simplify it, we get the value of b as 6 and minus 2. So we already calculated a value, that is 3, and then if we substitute b value here, b as 6 here, we will get one value. When b value is equal to minus 2, we will get another c value. So when a is equal to 3, b is equal to 6, and then c is equal to minus c, means c is equal to minus 9, means it will form one equation. When b value is equal to minus 2, we will get c value as minus 1. Already we calculated a value as 3. So when we substitute those values, we will get another plane equation. Hence we got two different plane equations. These two planes passes through the given points. I hope you understand this problem clearly. Now we move on to a very important NCERT problem. Prove that if a plane has the intercepts a, b, c and is at a distance of p units from the origin, then the equation of the plane is 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. Now we need to write the equation of the plane which makes this intercept, and then we have to apply distance between the plane and the origin formula. So first we will write the equation of the plane. So x by a plus y by b plus z by c is equal to 1. This can be again. So now we need to find out the distance between the origin and this plane equation. So before we apply the formula, we are just rewriting that equation: 1 by a into x plus 1 by b into y plus 1 by c into z minus 1 equal to 0. Distance from a point and a plane ax plus by plus cz plus d equal to 0. If the plane equation is ax plus by plus cz plus d equal to 0 means then the point coordinates are x1, y1, z1, then the formula is a into x1 plus b into y1 plus c into z1 plus d whole divided by coefficient of x, square root of coefficient of x square, coefficient of y square, coefficient of z square. We are going to apply that formula. So the point is 0 comma 0 comma 0, hence x1 y1 z1 is 0 and the equation is in this form. So in place of x we are substituting x1, in place of y we are substituting y1, in place of z we are substituting z1. Hence 1 by a into 0 plus 1 by b into 0 plus 1 by c into 0 minus 1 whole divided by, this one is coefficient of x square, coefficient of y square, coefficient of z square. Here coefficient of x is 1 by a whole square, here coefficient of y is 1 by b, hence this whole square, coefficient of z is 1 by c. The distance is already given as p units, and when we simplify it we are getting this expression, but we need to bring it to this form so we can transfer this to the opposite side. This p squared can be transferred to opposite side and we got the final value. I hope you understand this problem. With this we are completing 3D geometry. In the next video we will start probability chapter. Thank you students. Thanks for your cooperation.